We are getting closer and closer to being able to actually graph our polynomial functions. We know what the ends are going to look like. Do they both rise? Do they both fall? Does one rise? Does one fall? We know that depends upon the degree and the leading coefficient. We've found the x-intercepts. We know we need to factor the polynomial function and let y, or the f of x, equal 0. The last thing that we're going to talk about is the multiplicity. This is an important definition. For any factor, x minus r to the power of m, where m is greater than or equal to 1, then the multiplicity equals m. So whenever I ask you, what is the multiplicity? I'm asking you for m, the power on the factor. Let's look at an example. So we're given a polynomial function here, and we're asking you, first of all, to find the real zeros. We see that there are 3 of them. X equals 0, x equals 1, and x equals -3. What's the multiplicity? Well, this one's really easy to see. I see it has a multiplicity of 2. But what about here? The multiplicity of 1 here as well. What we're most interested in is whether or not the multiplicity is odd or even. We see here in this example that 2 of them were odd and 1 was even. And just a quick review question. What's the degree of this polynomial function here? Can you write that in? Yeah, it's going to be 1 plus 2 plus 1. I hope you had a degree of 4 there. So if you know that the degree is 4, what are the end behaviors of this graph? Well, for that we need the leading coefficient. That's going to be positive. This is even. So we know what the end behaviors are doing. Think about what we all know so far. We have real zeros, or x-intercepts, at 0, at 1, and at -3. And the end behaviors, because this is even and positive, we know that both ends are going to rise. Notice that I'm using the outside intercepts. For the ends. I'm not using this one in the middle. I'm using the outside. And both sides are falling. I mean rising. Rising on the left, rising on the right. Let's look here. Can you find the real zeros and their multiplicity? So we have a real 0 of 6. It has a multiplicity of 5, which is odd. We have a real 0 of -3 and a multiplicity of 2, which is even. We have a real 0 of -2 with a multiplicity of 1, which is odd. So what do we know so far? We have real zeros, or x-intercepts, at 6, at -3, and at -2. The degree of this function is 8. This is even. It has a positive leading coefficient That means both ends are rising from the outside. Make sure you're comfortable with the information we've got so far, and in the next lesson, we'll talk about how to use the multiplicity to finish graphing our polynomial function.